Hey everybody, Dr. Tracy here. Quick video to finish out chapter 2, and this week we discussed data types. Last week, when we talked about software development, it was kind of split in this chapter, and the previous chapter talked about the process as a whole, but the building blocks to that process are the data types that are accepted, retrieved, modified, accessed, and evaluated within the program. The most common of which is strings. Text processing is by far the most common application of computing because it's used in a variety of different areas. In those data types, the most common ways to set up data types is whether they are strings or values. Values are then defined according to their operations and how they are performed. Numeric data types of int and float are categorized according to whether they are integers or floating point numbers. This is an example of strings, integers, and floats. Integers are any number that doesn't have decimal places. Negatives are also considered integers, as is 0. Whole numbers, not whole numbers. Integers are whole numbers. Real numbers include decimal places. Anything past the decimal point defines that it is a real number and is considered in Python as a float. Strings are anything that doesn't have value. So letters or even numbers, if it's like a zip code, let's say. In Python, anything that you keep is inside a single quotation marks or double quotation marks represents a string. So anything between a set of quotation marks is a string literal, because that says these are exactly the characters that I want to display or use within this variable. Sometimes we have escape characters in there, and the escape characters are only so that the program knows that we need some things that are non-printing, like backspace or new line. Strings can be concatenated in the same way that integers or floating points can be added. You use the same operator. But when you join a string, you can join 2 or more strings to form a new string, and that's called concatenation. Concatenation allows you to build a string by repeating another string a given number of times. When we create variables, variables are the name we associated with these values that we're storing these data. You see, memory itself is built of a bunch of addresses. You can think of it like seat numbers in a theater or at a sporting event. If you sit in D12, then you know that you are in row D and seat 12 of row D in that section. Memory works the same way. There's sections and seat numbers, but basically it's a location where it can store a value for easy access later. Now, because we don't want to talk to our computer by ons and offs, we assign those names to those values. And so when a chunk of memory is stored in a certain location, the variable name that's associated with it will make it easier to remember and use later in the program. There are some rules for how you can name your variables. You can't use Python words. You can't start with a number. You can contain numbers, letters, or underscores, but it just can't start with a number. And they're case sensitive, so a capital letter is different. You can't use a space at all naming your variables. There are some things that people do when they're programming that is good practice. It isn't necessarily required, but if you create constants, people typically create constants in all capital letters. Program comments and docstrings. So when we look at program comments and docstrings, this is a docstring example. A docstring goes 3 quotation marks at the top and bottom. It's an indicator of where you can find information that pertains to the program, such as the author, the name of the program, when it was last modified, and the purpose of the program. These end-of-line comment examples use 3 quotation marks in order to show what they do. Okay, so let's talk about some numeric data types in here. Integers in real life, the range is infinite. But a computer has memory issues where infinite is not a possibility, even though it can handle very, very large numbers. We're talking about 2 to the 31st power, which extends out pretty far. Integers are written without commas. Python uses floating point numbers to represent real numbers, and floating point numbers are ones with decimal places, and they hold precision because they have a larger scale in which they're held. So sometimes when you see numbers, you have different, you see an E in there. That stands for scientific notation, which indicates just how big that is. 3.78 E0 is the same as 3.78 times 10 to the 0, or to the 1 or to the 3 or whatever. So the character sets, some characters that aren't in standard representation have different representation within Python, and we use those character sets, like the ASCII set or the Unicode set, to map the integers to the numbers that are used to represent them. An expression is a way to perform operations on data values to produce other values. 1 plus 2 is an expression. We have operators like addition, subtraction, multiplication, division, and we create arithmetic expressions that consist of these operands and operators that do negation, exponentiation, multiplication, division, quotient, which is a divisor without a remainder, and then remainder, or modulus, that's called addition and subtraction. The precedence rules of arithmetic expressions within Python shows that the highest precedence is evaluated first. First is negation, then it's division, multiplication, and modulus, then it's addition and subtraction, and then it's associated with whatever's on the left side. You can change this order of evaluation by using parentheses. These are examples of arithmetic expressions and the returning value that you would get if you executed those expressions. When both operands of an expression are the same numeric type, then it's automatically going to result in a value that is that type. If they are both integers, your answer will be an integer. When they are of a different type, the resulting value is of the more general type. So in this example where 3 divided by 4 is 0, 3 divided by 4.0 is 0.75. That's because 3 divided by 4, if they're both integers, the result's going to be an integer. 0.75 can't be an integer, and that just means that 3 cannot be divided by 4 using whole numbers only, so the result is 0. But if 3 is divided by 4.0, it looks like the same problem, but now we're dividing, we have an integer divided by a float. And so now it results in whichever one works, and so the answer will be 0.75. So be careful where you use integers and whole numbers, because it does make a difference in the answers. Mixed mode arithmetic and type conversions involves the use of floating points as well as integers, and it will typically result in a number that is a floating point unless you otherwise modify that. There's some example. If you otherwise modify that, that would use these functions like int and float. I'm trying to go back, but it's not letting me go back. The int and float indicate I can change an integer, 6.75, to an integer, and then it just becomes 6. But if I round the same float, then it will be 7 because it's still treating it like 6.75. Okay. So functions and modules are ways that we organize libraries of code within Python, and that's also included in this chapter. A function is a chunk of code that is called by one name. So if you have several instructions that are going to be repetitive and used throughout the program, it is a good way to organize your program by creating a function that possibly requires arguments or parameters and returns a value by executing statements that are characterized as part of that function. When we use functions that belong to other modules that have been written by those that came before us, we make sure to import those modules so we have access to those functions. For example, in this statement, the math module, there has to be an import math statement in order to use math.py or math.square root. Pi and square root aren't built into Python, but if you import them into your program, you have access to the functions that exist within the math program. You can avoid the use each time if you by importing the individual resources, or you can import all the resources to not use the qualifier. So instead of having to say math.py, I could say from math import pi, and then pi is just pi. That means I brought that particular function directly in and not just access to the module. The main module is how you write documentation, and the modules that we call in the program where it starts is the main module. That can be imported too. So here's an example of code where the main module is imported and then executed. Whenever you're programming, you should start with a structure. Start with a comment, with the author's name, the purpose of the program, and call that your docstring. Then you include any modules that will be needed by that program in import statements. Then you initialize those important variables, saying what data type they'll be initialized as. Then you prompt for any input data and save the input data into variables, finally producing the results and displaying those results. The program itself runs off scripts by saving the files within a .py file. And when we have our programs that end in .py, we can create outputs that runs those scripts, either from a terminal or a command prompt. So this is the end of this chapter, and just a summary of last week where we went over the phases of software development. And this week it is docstrings and comments, variables, data types, arithmetic operators, expressions, and operations in different data types, function calls, module calls, and the way that you set up your programming structure. So I hope this was helpful, and I will talk to you next week.